Okay, begin.
Okay, today we are going to talk about entering the world of GRU software radio. And this word GRU is has an iterative definition that GRU is not Unix. And I think GRU is an open source and free software standard. And here is the outline of the presentation. First, I will give you an introduction of the software-defined radio, and then I will introduce the hardware, and then Tan will give you an introduction of the software. Then we will introduce the GNU companion and give you some communication demos. Here is the general architecture of the software-defined radio, and it is usually comprised of three parts: the application processor and the baseband processor and the radio front end. For the application processor, it is usually your personal computer, your laptop, your desktop, or some portable personal device. And for the baseband processor, it is usually of a FPGA, and the radio front end is the antenna and some RF and RF conversion circuit. RF means radio frequency, and RF is a low frequency signal for the intermediate frequency. And among the software-defined radio, the USRP is one of the most widely used device. USRP is short for Universal Radio Prereversal, and it is the hardware solution for GRU software-defined radio. This one is the USRP1, and this one is the USRP2. Here is the hardware of the USRP1. For USRP1, it has 4 ADC and 4 DAC, and it uses a USB 2.0 interface to communicate with the computer. It has a small FPGA in it, and it supports MIMO. The price of the USRP1 is $700. Here is the hardware architecture of the USRP2. For USRP2, it has 2 ADC and 2 DAC. The speed is much faster. For USRP2, it uses a gigabit Ethernet interface to connect with the computer, because the bottleneck for the USRP1 is the USB interface. The speed of the USB interface is too slow, so for USRP2 they replace it with a gigabit Ethernet interface, and the USRP2 has a larger FPGA, so it's more powerful, and it can process the signals more faster. USRP2 has an onboard SD card here, so if you do not insert the SD card here, the USRP2 will not work. USRP2 supports MIMO. The price of USRP2 is $1,400, the double price of USRP1. Here are the available daughter boards of USRP. USRP has many daughter boards to support different frequency bands to communicate. The left two are the basic transmit, and the basic receive. This one is most commonly used on the Wi-Fi frequency band. It supports the frequency from 2.4 GHz to 2.5 GHz, and 4.9 to 5.9. And this one is for wide spectrum communication. It covers the spectrum from 15 MHz to 1 GHz. And these three are some antennas. This one is the directional antenna. So this is the block diagram of the software-defined radio. So in the receive path, the antenna receive the signal in the air, and in the doctor box, it converts the radio frequency signal to the intermediate frequency signal. So then the signal was transmitted to the USRP2 motherboard. On the motherboard, the signal was sampled from analog signal to digital signal and transmitted to FPGA. The FPGA will do the data rate conversion and timing and some other operations, and then the FPGA will send the data to the personal computer through the gigabit Ethernet interface. At the personal computer, you can do some signal processing operations like synchronization, modulation, and demodulation. And that's the receive path. For the transmit path, it just change the direction from the personal PC to the RF front end. And then I will detailedly explain the RF front end and the FPGA and some others. Here is the receive path of the RF front end. The signal from the antenna was first sent to the no-noise amplifier. Then it will processed by the low-pass filter. The low-pass filter will filter out some high-frequency noise, and then the local oscillator will down-convert the RF signal to the intermediate frequency signal, and then send it to the low-pass filter. The low-pass filter will obtain the signal of interest and send it to the ADC. The ADC will convert the analog signal to the digital signal. After converted, the signal will send to the FPGA. Here is the FPGA max for USRP1. At the USRP1, the sampled signal will through the DDC, because the data string are too fast for the USB transmit. So there are some down sampled converter here. It will load the data rate of the signal and send it to USB. Through the USB, the data will send to the personal computer and process it. Here is the architecture of the DDC. At the DDC, there is a oscillator, and it will be decimated by n times, and then the personal computer can process it. And here is the first example of the USRP. We will do a simple transmission. A simple sinusoid wave is transmitted, and we can view it and receive in the spectrum domain. So you transmit it.